Problem 40. The flashboard gate shown consists of a plane face BD resting in a groove at D and supported by the strut CE, which is pinned at the ends. Neglecting the weight of the gate, determine the greatest depth H which the water can have without causing the gate to collapse. So here is the given figure. Notice that the gate is free to it can collapse if the hydrostatic force acts above C. So it will create moment about this strut, so it will collapse here. So that it will not collapse, the force should act at C, or the center of pressure should be at C. So here we go. So because this is the given figure and the gate is not totally submerged, partially submerged only. So if this is the depth, then the distance from the centroid of the gate in contact with the water is half of h. So in other words, barred h is h over 2. Then this distance is, this vertical distance is also h over 2. So therefore, the distance from D to the centroid is h over 2, or 0.5 of h divided by sine of 45. And the height of the gate in contact with water is h divided by sine 45. So that's the location of the force. That should be the center of pressure. If the force acts above that strut C at C, then it will now start to collapse. The gate will now start to collapse. So E sub V, that's E sub V. The distance from centroid to D is h over 2 over sine of 40, or 0.5 of h divided by sine of 45 degrees rather. And therefore, E sub V, because this is an isosceles triangle, 90 degrees at C, this is also 2.4. So therefore, E sub V is 0.5 h over sine 45 minus 2.4. So E sub V is 0.5 of h over sine 45 degrees minus 2.4. CD is also 2.4 because that's 45, that's 90. This is an isosceles right triangle. Then the formula for E sub V is height of triangle in contact with the liquid or water square sine of 45 degrees over 12 barred h. It's a formula where this length in contact with the water is h over sine 45. Sine 45 is opposite h over hypotenuse. So the hypotenuse is h over sine 45. So substitute into the formula height of rectangle square sine of 45 over 12 barred h, where barred h is h over 2, or 0.5 h, equals 0.5 h over sine 45 minus 2.4, because CD is also 2.4. So simplifying, h squared divided by h, so h over 6 sine 45, because this sine square 45. So h over 6 sine 45 degrees equals 0.5 h over sine 45 minus 2.4. So 2.4 to the left equals h over sine 45, quantity 0.5 minus 1/6. So we can now solve for h. Then let's compare h with the height of vertical height of water if the water level is at B, which is 6 sine 45. If this is correct, that h is below B. So the result is 5.091 meters, which is greater than the vertical height if the water level is at B. So meaning to say, this value, this assumption or this analysis is wrong because we analyze it first that h is below B, but the result is greater than the height at B level. So meaning to say the liquid level is here. So if the liquid level is above B, then the gate is totally submerged. So we have to revise the analysis. So this is now the actual water surface. So this is now the H. Take note that this is now the centroid of the gate. The gate is totally submerged. So the height of the gate is 6 meters because it is totally submerged. Therefore, the distance from D to this centroid here is 3 meters. It's no longer 0.5 h over sine 45. It's now 3 meters. And the vertical distance from the centroid of the gate to the bottom is 3 meters, half of 6, 3 meters sine 45. So this is 3 sine 45. If this is h, then barred h, this is barred h. Barred h is h minus 3 sine 45. The vertical distance of the centroid to the water surface is h minus 3 sine of 45. So vis-a-vis this time is 3 meters because from D to centroid, that should be half of 6. D to centroid of gate, that should be half of 6. So 3 minus 2.4. Isa V therefore is 3 meters because this is the centroid of the gate which is totally submerged. 3 meters minus 2.4 because CD is 2.4. So Isa V is 3 minus 2.4, so it is zero point 0.6 meter. Then we equate it to height of gate, which is 6 this time because the gate is totally submerged. 6 square sine of 45 divided by 12 barred h is equal to 0.6. 6 square height of gate square totally submerged sine of 45 over 12 barred h, and barred h is h minus 3 sine 45 equals zero point 0.6. So solving for h is 6 square sine 45 over 12 divided by zero point 0.6, then plus 3 sine 45. So solving for h is 5.657 meters. And that's it. It should be above the B level. And since this is above the B level, that's the answer.